all. Now I am going to discuss question number 19 from the GATE 2021 paper Electrical Engineering. The question is an alternator with internal voltage of 1 at an angle delta 1 per unit and synchronous reactance of 0.4 per unit is connected by a transmission line of reactance 0.1 per unit to a synchronous motor having synchronous reactance of 0.35 per unit and the internal voltage 0.85 at an angle delta 2 per unit. If the real power supplied by the alternator is 0.866 per unit, then delta 1 minus delta 2 in degrees. The concept behind the question is power flow through a transmission line from generator to motor. To know the detailed modeling of power flow through the transmission line, audience can go through the given NPTEL video link. Let us discuss the useful information to solve the problem. Here, power flow through a transmission line is given by the magnitude of the sending end voltage into the magnitude of the receiving end voltage divided by the total reactance of the transmission line including generator and motor into sine of the angular difference between the two buses. Using this information, let us solve the problem. First of all, given data. Given it is that an alternator is there and the alternator is having a synchronous reactance of 0.4 per unit and the voltage of 1 at an angle of delta 1 is connected to a transmission line of reactance 0.1 per unit also, and it is connected to a synchronous motor of synchronous reactance is 0.35 and the voltage of the synchronous motor is 0.85 per unit at an angle of delta 2. Also, it is given that the real power supplied by the alternator P is equal to 0.866 per unit. This is the given data. So, we know that power flow through the transmission line is given by the magnitude of the sending end voltage into the magnitude of the receiving end voltage divided by total reactance into sine of the angular difference, that is delta 1 minus delta 2. Also, it is given that power flow is 0.866 and the magnitude of the sending end voltage, that is 1, and the magnitude of the receiving end is 0.85 divided by total reactance is alternator reactance plus transmission line reactance plus synchronous motor reactance into sine of delta 1 minus delta 2. So, if we simplify, 0.866 is equal to 0.85 divided by 0.85 into sine delta 1 minus delta 2 implies sine delta 1 minus delta 2 is equal to 0.866. From this, delta 1 minus delta 2 is equal to 60 degrees. So, the angular difference, that is delta 1 minus delta 2 is 60 degrees. Thank you.